implosive hydrogen and oxygen fuels versus explosive nanobubble water fuels. Thermatic fuels definition. Thermatic fuels are traditional fuels that release energy primarily in the form of heat during combustion. Mechanism. One combustion process. Thermatic fuels undergo a chemical reaction with oxygen, oxidation, releasing energy as heat. Common examples include gasoline, diesel, natural gas, and hydrogen when used in conventional combustion engines. 2. Energy release. The energy is released in the form of heat, which then causes an expansion of gases, performing work in engines or turbines. 3. Example, hydrogen combustion. When hydrogen combusts with oxygen, the reaction is 2H2 plus O2, right arrow 2H2O plus text, heat. This reaction releases a significant amount of heat, which can be used to produce mechanical work. Nanobubble fuels definition. Nanobubble fuels are a type of fuel created through a process where water is split into its constituent gases, hydrogen and oxygen, and then further processed to create fuel with unique properties, including missing electrons. Mechanism 1. Voltrolysis and electron extraction. Water is subjected to high voltage, voltrolysis, to split into hydrogen and oxygen, and electrons are extracted, leaving positively charged oxygen OPs. 2. Nanobubble formation. The water is atomized into nanobubbles, creating a fuel where the oxygen is in an energized, positively charged state, O with missing electrons. 3. Energy release. When ignited, the fuel recombines hydrogen with the positively charged oxygen, releasing a large amount of energy rapidly. The stored electrons are reintroduced during ignition, allowing the oxygen to regain its electrons and form water. 2H2 plus O core plus, right arrow 2H2O plus text, explosive energy. The energy released is more forceful and less reliant on heat compared to traditional combustion. Differences between implosive hydrogen and oxygen fuels versus explosive nanobubble water fuels. 1. Combustion versus electron recombination. Implosive hydrogen and oxygen fuels. These fuels combust by combining hydrogen and oxygen to form water, releasing energy as heat. The reaction is generally controlled and produces a consistent, steady release of energy. Explosive nanobubble water fuels. These fuels are ignited by recombining hydrogen with positively charged oxygen, with electrons being reintroduced during ignition. The energy release is rapid and explosive, producing a forceful reaction with less heat compared to traditional combustion. 2. Heat versus force. Thermatic fuels, e.g. hydrogen combustion, primarily release energy as heat, which then drives mechanical work through the expansion of gases. Nanobubble fuels release energy in a more forceful, explosive manner due to the recombination of atoms and reintroduction of electrons. The explosion is characterized by a high energy release that is more focused on force than heat. 3. Chemical stability. Thermatic fuels, stable and readily available for combustion with oxygen molecules in a stable state. Nanobubble fuels include oxygen in an unstable, positively charged state, which cannot readily form water without the reintroduction of electrons. This instability contributes to the explosive nature when the fuel is ignited. Summary: thermatic fuels utilize combustion, releasing energy primarily as heat, driving mechanical work through the expansion of gases. Nanobubble fuels created through voltrolysis and electron extraction, these fuels release energy explosively with more force than heat upon ignition, involving the recombination of hydrogen and positively charged oxygen, and the reintroduction of electrons. Understanding these differences helps highlight why nanobubble fuels represent a unique and powerful alternative to traditional thermatic fuels.